So I wanted to make a video with the examples that are in section 11.4, just the examples, not interspersed with the text. So that's what I'm going to do here. So the first example is right after the formal definition of the tangent line slope. So there's an example A that says g of x is 1 minus 2x squared, and at x equals -1, we want the slope of the tangent line. So this is a multi-step process. You can combine some steps if you're confident and comfortable doing that. I'm going to do it step by step. So I need g of a plus h. So I put a plus h everywhere x is. So that's going to be 1 minus 2 times a squared plus 2ah plus h squared, because we've done this a lot of times now. And then we're going to distribute the -2, so 1 minus -2a squared minus 4ah minus 2h squared. So that's step 1. Step 2 is do the difference, g of a plus h minus g of a. So if g of x is 1 minus 2x squared, g of a is 1 minus 2a squared. So I'm going to copy my g of a plus h, 1 minus 2a squared, minus 4ah minus 2h squared minus, and make sure you put this parenthesis, 1 minus 2a squared, which is g of a. So now I'm going to simplify. 1 minus 2a squared minus 4ah minus 2h squared minus 1 plus 2a squared. So the 1's cancel, the 2a squareds cancel. I'm left with minus 4ah minus 2h squared. Then the next step is to divide this by h. So you take step 2's result and divide it by h. So I'm going to factor out h and divide by h, so the h's will cancel. And I have -4a minus 2h. So at this point, what I have is called the difference quotient. And then the next step is to do the limit as h goes to 0 of the result from step 3. So that's of -4a minus 2h. So that's going to be -4a. Then the very last step is when, and this was when x is -1. So it's when x or a is -1, whichever variable you're using, doesn't matter which one you call it. So -4 times -1 equals 4, and this is m, the slope of the tangent line. So later in the notes, it asks you to find the equation of the tangent line. So this is the slope of the tangent line. So now let's talk about the equation of the tangent line. So that needs to be an equation of a line. So you need a y-coordinate of the point when x is -1. So you need to find g of -1. So you plug that into the function. Because what's happening here is this is the point where the tangent line and the graph of g touch, is at this point. So it's on both things, the curve and the tangent straight line. So this is going to be -1. So the point -1, -1 is my point that I know is on the tangent line. And so I can write the equation of the line as y minus -1 equals m, which is 4, times x minus -1. And if you want to write it in y equals mx plus b form, which the answers in the back of the book always do, so you're going to have 4x plus 1. Let's distribute the 4, get 4x plus 4 on the right, subtract 1, and get y equals 4x plus 3. So this is the equation of the tangent line to the function g of x. Let me make that 4 look better. At the point where x is -1.